Quantum entanglement is perplexing and useful, but it's quite the phenomenon. It's only one aspect of quantum mechanics, and we're finding it's an essential part of behavior of the nature of the atomic and even subatomic levels. Two particles in quantum mechanics are said to be entangled when one of the particles cannot perfectly be described without including all of the information of the other one. The particles are essentially connected. They're connected in such a way that they are not independent of one another. Well, this sort of idea seems to make sense at first glance. It's a difficult concept to actually grasp. Physicists are still learning more about it as we speak. The classic example of quantum entanglement is called the EPR paradox. In a simplified version of this case, consider a particle with a quantum spin 0 that decays into two new particles, particle A and particle B. Particle A and particle B head off in opposite directions. However, the original particle had a quantum spin of 0. Each of the new particles has a quantum spin of 1/2, but because they have to add up to 0, one of those is plus 1/2, while the other is negative 1/2. This relationship means that the two particles are entangled. When you measure the spin of particle A, that measurement has an impact on the possible results you could get when measuring the spin of particle B. And this isn't just an interesting theoretical prediction. It's been verified through experiments, through tests of Bell's theorem. One important thing to remember is that in quantum physics, the original uncertainty about the particle's quantum state isn't just a lack of knowledge. A fundamental property of quantum theory is that prior to the act of measurement, the particle really doesn't have a definitive state, but it is in a superposition of all possible states. This is best modeled by the classic quantum physics thought experiment, Schrodinger's cat, where the quantum mechanics approach results in an unobserved cat that is both alive and dead simultaneously. From emerging computers, man-made technology, to the natural world, we're learning more about this essential, intelligent design of everything around us. And only time will tell how deeply we have come to understand this aspect of the natural world. These are interesting things with JC.